So, hello. Last session we have discussed about semaphore. What is a semaphore? How it works. Okay, what is the need for semaphore? All these things we have seen in the last session. Today we are going to see how to implement semaphore in code. Okay, implementing semaphore in code. So there are three calls that are primarily used for semaphores, and these three calls are semget, semctl, and semop. We'll see all the three calls one by one. First, semget. Now the semget system call creates a new semaphore array. You always create a semaphore array, or obtains the semaphore key of an existing semaphore. Now you remember, there was a concept of user key and kernel key that applies to semget also. Now once the semaphore is created, look at the first argument of the semget. It is a key that is supplied by the user. Okay, just like you supplied some key in the message queues and shared memory, similarly you supply some key as argument number 1. Yeah, this is the user supplied key. Okay, which will be given by the programmer, the user, so as to identify the semaphore array to which to hinge on to synchronize access to some shared resource. Users key underscore t, first argument is users key for semaphore, for identifying semaphore array. Okay, it is users key for identifying the semaphore array, which will be provided by user. Yeah. Now I told you that we create semaphore array. Now if you are creating semaphore array, then what is the size of array? How many elements do you have in the array? Well, that will be decided here. The third argument is number of semaphores. It is basically it basically tells you the size of the semaphore array, or in other words, it tells you the number of semaphores that you are going to create in this code. So first argument was key underscore t. It is used to allow unrelated processes to access the same semaphore. It is actually the user supplied key. Okay, and it will be used to allow unrelated processes to connect to one single semaphore. Okay. The semaphore is identified this way. All semaphores are accessed indirectly by the program supplying by this key. If you want your semaphore to be restricted to the current process, you can also make it IPC private. Okay. It is a key identifying the semaphore array. You can make it IPC private also. If you make it IPC private, then the semaphore will be visible only to the current process and nobody else. This is semaphore array size. We never create a single semaphore. We always create an array of semaphores. So this variable gives you the size of the semaphore array, or in other words, it gives you the number of semaphores to create. This. We never create a single semaphore. We always create an array of semaphores. So this variable gives the number of semaphores to create, or it gives you the size of the semaphore array. So I think it's crystal clear to everybody what we are discussing. Then finally you have some semaphore flags that you are going to use. Okay, this is IP66 IPC create. 66 will be permissions, and then IPC create is a flag that will be creating the semaphore, used to create the semaphore. Or you can also make it IPC EXCL, means exclusive, means the current semaphore is exclusive for the current process only and will not be visible outside of the current process. So these are the two possibilities that you can give for semaphore flags. Okay. Now once the semaphore is created successfully, then it will return the kernel's key for the semaphore. The return value is the semaphore identifier used in other semaphore functions This is the kernel's key for semaphore, or it may give you -1 for error. So this is how the semaphores are created. Okay. Have a look at this subject and tell me if there is anything that you are not able to understand. This returns the kernel key, or it will return -1 on error if in case you fail to create some kind of semaphore. SemGet, I think everybody is okay with this. SemGet.